this is just a quick video that's looking at how we can calculate surface area to volume ratio. So this question was found in the most recent progress assessment, and it's a foundation from the foundation paper. So what we've got figure 3 shows two cubes. The surface area to volume ratio for cube A is 6:1. So you've got cube A, which has a value of the length, the width, the height of 1, and cube B, that's got a length, width, height of 2. So the question is, calculate the surface area to volume ratio of cube B. So this one, it's 4 marks. So because this is from the foundation paper, it's given you 4 steps really to go through in order to ultimately calculate the surface area to volume ratio. So to work out the surface area of one face of cube B, so think about what you do in maths to work out surface area, that's your length times your height, so basically times in 2 sides together. So here we're going to do 2 times 2, which gives us 4. So that's the surface area of one of the faces. Because this is a cube, it's actually got 6 faces in total, so if we have a look, it's got 1, 2, 1 around the other side, so that's 3, 4, 1 on the top, 5, 1 on the bottom, 6. So we're going to work out the total surface area as being the area of one face times by 6, which gives us 24. So to work out the volume, just like in maths, volume is the length times the width times the height. So we're going to do 2 times 2 times 2, which gives us 8. So that's a total volume of 8. We pop that into the surface area to volume ratio here, so that's 24 to 8, because that's as total surface area to the volume. So then we need to think about what's the greatest common factor to simplify this ratio. So here there are 3 8s that go into 24, and there's obviously just 1 8 that goes into 8, so that gives us a simplified ratio of 3:1. So the next question, it says a scientist investigating the effect of surface area on the effectiveness of a nanoparticle catalyst. So you've got a diagram and it's given the values of the sides as being 4, 4 and 4, so the length, the width and the height. And it says calculate the surface area to volume ratio of the cube, 4 marks again. So if you think about those steps to success, step 1, you work out the area of one side using the length times the height, just like maths. Step 2, you multiply that by 6 because the cube, it's got 6 sides. Then step 3, we're going to calculate the volume using length times width times height, just like maths again. And then step 4, we're going to basically simplify the ratio. So if we look at this question again, if it's foundation, would be given the kind of framework to use. So here we're using 4 as our numbers from the diagram. So to work out the surface area, doing 4 times 4, which is 24. So the total number of sides is 6. So we're doing 6 times 24, that gives us the total surface area. Then to work out the volume, we just do the length times the width times the height. So 4 times 4 times 4, which is 64. And we pop it into the surface area to volume ratio, and we get 144 to 64. Then want to simplify that. So that gives us a simplified ratio of 9:4. Okay. So what we've got to do to get the simplified ratios, we've got to think what's the greatest common factor that goes into both of these numbers. So you can check out the Essential Skills ratio simplify video on YouTube for a little bit more help on this final simplifying ratios step, or you can find the video on 999 Maths. So I want you to have a little go now at these 2 questions. So we've got question 1, which is a microbiologist is measuring the size of a different cuboid pollen spores. So we've got 3 micrometers for the length times the length, the height, the width of this cube. And then question 2, a student's investigating the density of different solid objects. One of these is an aluminium cube shown below, and the length, width, height is 5 centimeters from these. So you need to calculate the surface area to volume ratio of the cube, 4 marks for both of the questions. So what I'd like to do is pause the video now, and then you'll be able to find the answer in just a second. So pause the video and have a go. Right then, well done. So just to So you can check your answers. For question number 1, the answer is a ratio of 2 to 1 for the surface area to volume ratio, and that's the simplified ratio. And then for question 2, it is 6 to 5. So well done. You can pause the video now, and if you're not sure, just start the video again for a little bit more practice. Well done.